Morning. Buongiorno, good morning. So, the students who are attending online, can you please confirm to me that you hear well? Somebody should...
Yes, Professor.
Hi,
Okay.
We can hear you.
Good, perfect. Thank you very much. So, good morning, and my name is Alberto. I am very pleased to meet you. This is the first edition of this subject, of this course. So you are a kind of guinea pig for me, and this is an honor for you, you know. And so, given that this is the first edition, I have to give you a lot of information this morning. I would say that these first 3 hours will be dedicated more or less 90% to delivering information. So take this opportunity, if you have any question related to the course, the exam, etc., take this opportunity to ask any question you may think about. There are no silly questions. I am recording from now, so everything is videotaped and will be posted on YouTube and Virtuale. So the students who are not attending today have the opportunity to listen back to what I'm saying. Okay. Now, first, you know that this subject is open in principle to students from School of Engineering and the students who are, let me call them, not engineering students. And this is not a kind of diminutive status. I would say the opposite. Anyway, can you please raise your hand if you are a non-engineering student? Okay, very good. And I think there must be more than that. Okay, this was my idea, to give the opportunity to attend this class also to students who are not studying engineering. The reason is that there are many reasons, but the most important is probably the fact that I realized that climate change is really interdisciplinary. Everybody agrees on that, but nobody does that. So everybody says we need interdisciplinarity to deal with climate change. But in practice, if you look at the outcome from any action, there is little interdisciplinarity. And I think this is a major problem today. So I think it's a major problem that we are talking about climate change, everybody talking from its own discipline and not exchanging information. There are many reasons for that, but I think that we have to do something in order to avoid this problem, because actually this problem is undermining our capability to take action. So this was the main reason for this idea, like why should we teach climate change only to engineering? I know that at the University of Bologna there are other courses in Italian on climate change. There is also another course that I'm teaching, which is a soft skill. It's called the Science of Climate Change and Climate Actions. Can you please raise your hand if you're attending also this other course? Okay, 3 people, perfect. Keep in mind that there will be some overlap. So not really a lot of overlap, but there is some overlap. For instance, today I am teaching in the afternoon at Science of Climate Change, and the introduction is the same for both courses. But you know, it's the spirit is very different. Science of Climate Change is very basic, it's very narrative. Here it's a little bit more technical, not very technical, but a little bit more technical. And also Science of Climate Change talks in general about climate change. Here we talk about climate change adaptation. I will explain to you what's the difference between climate change mitigation and adaptation. Okay, so the first reason was that I wanted to seek an interdisciplinary approach. The second reason why I had this idea was that teaching Science of Climate Change, I realized that there were many requests to attend the exam. And we have only 200 seats and they run out very quickly. Once it's opened the subscription. So I thought that it may be interesting to give another opportunity. And how should we be able to, to deliver this subject to two different audiences? I think it's not difficult because there is a general part which is not very technical. Of course, to the students who are not studying engineering, I am aware that we should limit the technical part because, of course, it's a different perspective. So my idea is that I will separate clearly the general part of the course from the parts that are more dedicated to engineering. And my suggestion for the students who are not studying engineering is to attend anyway the parts which are basically specific for engineering. They will not be very technical. On the other hand, I think it is also an interesting experience to see how, from a technical point of view, an engineer thinks, how an engineer develops strategies. And of course, for students not of engineering, this part cannot be included in the topics for the exam. So I will make two separate exams, okay? And it's not a problem for me because, as we will see, the exam is organized in a quiz and an oral part. So it's not a problem to make two different quizzes. And it's not a problem in the oral, of course, to make a difference. I just need to know if you are a student of engineering and not of engineering. Of course, you shouldn't compare the marks that you get because there is also a difference. And for engineering, there are some criteria for other students who are choosing the course as an elective. The criteria are different. So you shouldn't compare the marks, but I think it's not really a big problem. And I'm really curious to know your opinion on this idea, because I know that I am expecting about 10 students, not from engineering. And so I'm really curious to see if it works. I think it's interesting. And also I think for your CV, the fact that you attended a course, an elective course, given by a technical school, it's maybe a distinguishing feature. So it's something that I think it's interesting. Okay. So this is the first thing that I wanted to say. Second thing, this is a course that is delivered half in presence and half online. So you know that on Monday we are attending in presence, and on Thursday it's online. On Thursday, I will try to concentrate a practical part, which is dedicated to developing some exercises. In some of the cases, to the students who are not from engineering, I will explicitly say that probably some lectures on Thursday dedicated to solving exercises are those that I may suggest to skip if you had to make a selection. And I will tell you, next Thursday is still a theoretical lecture, so it's not part of these exercises. But indeed, the exercises may be that they are, for a non-engineering student, the less interesting part. Still, I think that learning how to use computational open source software is useful because I don't think it is complicated. You don't need really, a technical background for that. On the other hand, I understand that you may also be forced to make some selections. And so I think it is useful if I say that probably the exercises are the less interesting part. And in any case, for everybody, keep in mind that the exercises are not a subject for the exam. So, even if I highly suggest also to students attending engineering courses to make these exercises, because the applied part is what I think what really characterizes engineering. So in engineering, we should apply besides studying the theory. So I highly suggest to engineering students to attend the practical exercises. On the other hand, keep in mind that I don't have any monitoring on who is attending or not, and the practical exercises are not a matter for the exam. There are no questions in the quiz and in the oral dedicated to solving exercises unless I ask you to make a very basic computation that can be done on paper. So you don't need any, I mean, or in the quiz, it may happen that there are some basic computation. The last exam of the other course, some students asked me, can I use my pocket calculator? And I said yes, because there were some very basic exercises, but not really, there is not a written part that is demanding a lot of computational resources or a lot of technical knowledge. Okay, so let me go back a little bit on the organization of online and physical presence lectures. I took the decision to stream every lecture. So even on Monday, I am teaching in streaming. You see on the screen there are several students, not several, but I mean 5, 8 students attending online. You have to consider this like an exception, because actually the university recommends that when the lectures are in physical presence, the videos can be distributed, but the university recommends not to teach in streaming. And the reason is that they want to, in a way, to encourage the attendance in physical presence. I decided to make this exception. It's my own initiative, because I know that for some students attending in physical presence, this academic year is still a problem. And therefore, I decided also to teach in streaming. So even on Monday, if you decided to attend in streaming, it doesn't make any difference for me. Of course, I like to see students in physical presence. Now we have also to discuss about the size of the room. I like to see students in physical presence. But on the other hand, I perfectly understand if you decide for many reasons to also attend online on Monday. It doesn't make any difference, again. On Thursday, of course, everything is online. About the videos, everything is recorded, and everything will be put online, as I said, on 2 channels. One is YouTube, and the other one is Virtuale. I decided to put the videos on both of them, because you have to know that I started putting the video of my lectures on YouTube in 2012, so already more than 10 years ago. So I was used, you can find on YouTube my lectures, 10 years of lectures, I was used to that. And I was quite a unique case. And of course, after the pandemic, I'm not unique anymore, and I would say that this is a good thing. And so I started with YouTube because I didn't have any additional channel. By doing that, I realized that my YouTube videos got a lot of visualizations from all over the world, and I got several notes of appreciation. So I decided that, I am a fan of open teaching, open source, open everything. So I decided, even after the pandemics, to continue posting on YouTube. YouTube now is putting advertisement. They started a couple of years ago. This is unfortunate, but on the other hand, I prefer not to change the channel, because I think it's still very efficient, and also, you know, changing the channel creates a discontinuity. So I am continuing on YouTube. I apologize if you see some very short advertisement at the beginning. Of course, I'm not monetizing anything on YouTube, but they put advertisement anyway, even if you are not monetizing from the visits to the videos. Of course, it's education, I'm not monetizing, but they put advertisement anyway. So I apologize for that. They are very short because I'm not monetizing, so it's not a long, but still you have to see something before they start. For this reason, I also decided to go on Virtuale, but Virtuale unfortunately is closed. So if you are not subscribed to the University of Bologna, or after you take your degree, you cannot have access to Virtuale anymore. So I don't think going only on Virtuale would be a good solution. So I decided to post both of them, to post on both of them. And you will find the videos very soon after the lecture, but give me maybe a couple of days. I'm teaching a lot in the second semester, so sometimes I have a delay of a couple of days, but not more than that usually. And before sending an email by saying, Professor, where is the video of Monday's lecture? Wait a couple of days, please, because otherwise I'm getting emails after a couple of hours, and this is a bit of a problem. Okay, now, after this very general premise, let me go to, if you have any question, please stop me, also online, no problem. And let's jump to my web page where you can find every information that you need. So in principle, I'm working on my web page and also in parallel on Virtuale for the same reason why I am posting on both YouTube and Virtuale. I started posting on my web page, my tutorials in the form of web pages a lot of years ago. You will see from about 2015. I decided to adopt as a repository for my teaching material, teaching documents, teaching tutorials, my web page, because at that time it was the only possibility if I wanted to be open. There was no other possibility. Also, the university gave a repository that was closed, but it was getting only PDFs. And I wanted instead to use web pages. Why? Because I can use links. I can update them online very, very easily. So this is why I decided to build my own website. I also like web publishing. I also think that if you want to make research, it's a vehicle that is extremely important nowadays to have your own repository where you can publish opinions, publish what you do. I mean, in order also to get visibility, but for the purpose of disseminating what we are doing. So I started with my web page, and then, of course, the university evolved, and now there is Virtuale. It is more or less giving the same possibilities, with the only exception that is closed. And instead, I think that it is extremely useful for the students, especially after the degree, to be able to go back and get updated information. And so I'm keeping both channels, and they are mirrored, but what is for sure updated, I first update my web page, my website, and then I mirror on Virtuale. So why I'm saying this? Because it may happen that I forget sometimes to mirror something. So you may find differences. If you see that something is missing on Virtuale, please just send an email, and that's okay. And also the web pages are continually updated. So I don't suggest you to download everything now and to get everything offline because they are updated. So, of course, you may download something, but in my web pages you find everything is needed for this course from now to June. So I don't suggest you to download everything, just wait, because I mean, accessibility to the network and the web today is not a problem anymore. And given that these pages are continuously updated, you may find some errors, or some spelling errors, some conceptual errors it may be. So if you see anything that it's not clear to you, anything that may look erroneous, please do send an email. I got a lot of suggestions from students in these years, and I think this is also a nice opportunity for me to learn something together with you. Okay, so here in my webpage, you find everything. And, we are interested in the tutorials of climate change adaptation. So if you're interested in what I'm doing in general, you find everything here, okay? Because it is my commitment, everything I make to try to put in real time everything online. There is an exception now. I am very busy with the National Recovery Plan. I didn't have time to understand how it works. So for this reason, it is very complicated to understand how it works. So for this reason, I am still not publishing anything. But in the National Recovery Plan, for your information, I am again in charge of finding solutions for climate change. So it is something that I hope I will be able to include here very soon. So let's click on tutorials of climate change adaptation. And here you find everything I am saying now. And I'm keeping this page in front of me because so I don't forget. But as I said, in principle, everything I'm saying can be found here. And this is the purpose. So before talking of what we are studying here, I go to the logistics first, okay? And then I will make an introduction to explain to you what we are talking about here. Okay, so online I already said everything. So YouTube Virtuale. I already said here you can find the links. So in the YouTube channel, if I click on the link, just a second, because, okay, accept. It should be empty. It's empty, of course. But starting from tomorrow, you will find here the lectures, the videos. Okay, let me go back. And Virtuale, same thing. I'm not going on clicking on Virtuale now, but same thing. Okay, let me just first say one thing. I really would like to interact with you, and there might be several ways of doing that. For instance, in the past, I gave the opportunity to the student to deliver short presentations. We are talking about climate change, it's a big issue. So it would be interesting to know what is your view on climate change. And these short presentations can be delivered during the lecture in order to have a discussion. And short means 5 minutes. So it means 6, 7 slides. I think it is a very good opportunity for you because you learn how to, it's not easy to present in front of an audience of 30 persons or more. And it's not really easy. So it's a good experience. And I think it is a good opportunity, as I said, to exchange views. The only thing that I ask you, the subject of your presentation shouldn't be something that is dealt with during the lecture. It should be an extra, because of course I am in charge of teaching what is delivered during the lectures, and I'm not asking you to teach instead of me, okay? So you shouldn't deliver a presentation on the subject of the lectures. The presentation should more be related, for instance, to case studies, to something like something that you witnessed and which you think may be a consequence of climate change due to the impact of climate change. To engineering students, I suggest also to include something technical, because if you are an engineer, you should be focused on the technical aspects of it. So it shouldn't be only narrative, like climate change is important, etc., etc. And I suggest you to focus on the science of it, not on the politics and economics of climate change, because we are not studying economics here and not political science. So, of course, I know that climate change is also relevant to economics, to political sciences, but I suggest to engineering students to focus on engineering. If you are a student of another school, you should focus on the main subject of your school. So if you're a student of economics, it would be interesting to know your perspective on the economics or what you're studying on the economics of climate change. If you're a student of political science, it's the same thing, okay? Or I know that there are students of the degree on international management or something like that. It would be very interesting to get your perspective, but of course, not technical, or let's say not focused on the engineering of it. And there might be other ideas for interacting. And I know the most usual way to interact is to ask questions. And I really appreciate if you ask questions, if we dedicate some time to discussion. I know that this is not easy. Every time I say, please ask me questions, and even if I stop and I ask, please, do you have some questions? It is not easy to stimulate students to ask questions. I understand that everybody's shy, and so I don't really know how to do this. If you have any suggestion, I will ask questions, but you will see that I am expecting that most of the time you will not have any question. And I really appreciate if you ask questions, and nobody is nobody is evaluated for that. So there is no positive outcome other than giving all of us the opportunity to discuss, and there is no negative outcome at all. Of course, there are no stupid questions. Okay, I will also ask you to, besides the usual questionnaire on the student's opinion that is delivered after 2/3 of the lectures in April, May, I will ask you after about 3-4 weeks to fill a form which is anonymous on your opinion on the teaching and to get your suggestion. This is very useful for me because, you know, the form, the official form of the university comes at the end of the subject and doesn't give the opportunity to change something, okay? And I also really would like, given that this is new, to get your indication if you have something that, if you have suggestions to improve it. Usually, I get three main criticisms. Some students say that what I'm teaching is too naive. Some students say that what I'm teaching is too complicated, too technical. So, of course, I try to make my best, but every year it is the same thing. So every year there is somebody approaching me and saying, this is too narrative, too naive, and somebody saying too technical. So, and the third thing is that somebody says that I'm speaking too fast. So I'll try to make an effort. Now, today is delivery of information, so I'm not making any effort to speak slower. When it becomes more theoretical, I will make an effort, but it is very difficult for me. You should be aware of that. So please tell me, okay? Tell me if my English is not good. It may happen, because especially when I get tired, and especially at the beginning, it is very hard for me. So tell me, and also tell me if I'm speaking too fast. No problem, okay? Okay, now, tutorials. Here there is a list of links. So let me just give you an example. The Earth system. If I click on it, you get a web page with the subject of the lecture. In some of the cases, there is a PowerPoint at the end. Here, I don't think there is a PowerPoint because I still have to prepare it. Just 1 second. No, there is no PowerPoint here, but in some cases, at the end of each lecture, you will find a PowerPoint. Let me just to explain. This is what you have to read/study, okay? So like a book. And keep in mind that I will say this later. What I am asking at the exam is included here. You will not experience any question at the exam that is not treated here. Usually this is more than that. So here there is more information. In some of the cases I will tell you, look, this is for your information, but not for the exam. In other cases, yeah, sorry, you're right, I'm not sharing the screen. Just 1 second. I apologize for that. Okay. Just 1 second. Good. Now you should see it. So, again, usually I tell you if something is redundant for your information only. In any case, it's not a stupid question, absolutely. If you ask me, but this may be a subject for the exam or not, please don't worry of that. I want to be very clear on what is the information that I'm delivering because I think it is very useful for your education, and what may be a question during the exam. I want to be very clear on that. And the reason is obvious. I mean, I think you don't have to study for the exam, because studying for an exam is different than studying for your education, for your information, for building your CV. It's a different story. On the other hand, you have to pass an exam. So I think that you have to be able to combine the two things. You don't have to study only to pass an exam, but you have to pass the exam. So the objective is to pass the exam, but also to build a good CV, a good education. So I think that this can be reached if I am very clear. And of course, you can make your selection. If you want to study just to pass this exam, this is not my advice. You may get the max mark, but please beware that in order to get a good career, it's not enough to have a good mark at the degree, okay? What matters is your interview later, and what matters is your first experience during the workplace, and then you need more than an high mark. And I saw several cases of students with a mark at the degree that was not good, which had an excellent career, and also cases with the opposite. So I think my advice is, of course, you have to get a good mark at the exam, but not only that. So I want to be very clear. And so these web pages are conceived as a book, and the result is that they are not very good to be used during the lectures. So for this reason, I'm also preparing PowerPoints, which I usually make available at the end of the lecture. And the PowerPoint usually is what I use during the lectures. Don't study on the PowerPoint. So don't make the mistake to think like it's much quicker to study on the PowerPoint. If you only look at the PowerPoint, it's not enough. In order to prepare your exam and to build your CV, your education, you have to look at the web pages. The PowerPoint is just useful for you to get the most from the lectures. But if you don't attend the lectures and or when you prepare the exam, you have to look at the web pages. Keep in mind that I will make an effort to have a PowerPoint every time. It may be that some of the lectures I will not be able to prepare it. And in this case, I may use the web pages to display them on the screen just as a reminder for me to remember what I have to say. Okay, but I will make an effort to use PowerPoints. I just want to make you aware. This is the list of the lectures and the links. This is not final, meaning that something can disappear and something may come later. I think it is more likely that something disappear rather than something coming later, but just note that this is not final, okay? But I am putting everything I am planning at the beginning already available, because students asked me in the past, they preferred to have an overview, at least of what is in my mind, so they know at what stage we are, etc. Okay? And I think that there will be probably some additional link on some interactive exercises, but in terms of content, I think this is more than enough. Probably will not be able to make everything here. Later on, you have links for the exercises, and I mean, don't worry about them now, because we need to make an introduction, and probably we will not be able to make everything here. I just put it there on our provisional list. Okay, now videos. This is our calendar. Videos, I already told you what I had to say, okay? And here there is, here I am asking 1 week in order to put the videos online. Usually 1 week is just safe, because now it's what you write must be safe, you know, but what you say may be a little bit more uncertain. So actually videos will be available after a couple of days, but I just put 1 week in order to make a safe statement. The calendar. This is the calendar that I'm planning now. There might be changes. There are some breaks there. And for instance, besides the Easter break, I think there is a break at the end of April. So you see that there is a jump between, there is the Easter break around here. April 3rd, April 13th, there is Easter in between these 2 dates. And then there is a break here. From April 20, we are jumping to May 8th. And the reason is that I have to attend a conference in the last week of April, and therefore I will not be able to teach. And then there is May 1st that is taking one date, one available date for us. So there is a little jump. We should be able to complete everything by May 22nd. Maybe that we can anticipate, I'm not really sure. Let's see. For now, this is the provisional list. Also, one of these dates will be dedicated probably to a field trip, but I still have to check if the university is providing the financing for it, the funds for it. Let's see. Okay, but this is our calendar with the specification of online, physical presence, etc. Exam. Okay, so it will be a quiz plus an oral. The quiz is lasting 30 minutes with 30 questions. And I mean, I decided a couple of years ago during the pandemics to try the way of the quiz. It is more or less a good positive experience. Also, the students provided a good feedback. Before than that, I was only making exam as orals, but I think the quiz is for some of the students is much better. First of all, the dates. The dates will be decided very soon, and there will be, first of all, keep in mind that I cannot make any exam before the official end of the lecture, which I think is June 6, something around that date. I have to check. I will make an exam soon after that date. So if it is June 6, the last lecture day, probably June 7, June 8, there will be an exam. And then I will make another appeal, another exam after 2 weeks, end of June. And then another one before the end of July, around July 15. Okay, so there will be 3 opportunities before summer. Another one in September, and this would be the 4th. And because in principle I cannot make exam during the lectures, so in September it will be before the start of the lectures. And then I am planning to make another one just before Christmas, would be the 5th exam after the end of the lectures. So next year I already have the dates, but I don't remember them. I hope it is possible, because of course if the lectures stop on December 22nd, it's not possible to make an exam on December 24th. So if it is possible, I will make an exam in December, and for sure another exam in January and another one in February. So basically, you know that we are required to give 6 opportunities during the academic year to take the exam. So there will be 3 before summer, 1 in September, and 2 opportunities between December 20 and February 15, 2024. These dates for the before summer round will be decided very soon. I need to book a lab, because to make the quiz we need a lab. So I first need to check the dates with the lab, and then I will let you know what the dates are. This will be, I think, by a couple of weeks. Okay. It may happen that at some of the exams there are few students only. Usually I say that if there are less than 5 students, the quiz will not be done, because I think it is really, I mean, if there are only 3 students, it doesn't have a lot of sense to make a quiz, and that doesn't make a good case for a quiz. But in any case, I will discuss this with you, okay? And this applies especially to students who ask for an extraordinary exam. Sometimes it happens. Some students ask me extraordinary exams, and in this case, usually it's for 1 or 2 students. So when it's extraordinary, it may happen that I say, okay, that's fine, but I make an effort to make you comfortable, but on the other hand, please also make you an effort and let's avoid the quiz, because otherwise it's not really convenient. Okay, the quiz will be, we'll use closed answer questions with no penalty. Okay, so in case you are in doubt, just toss the coin, because there is no negative impact if you make a mistake. With only 1 reply correct. So there are no cases with 2 correct replies. And usually the timing is very comfortable, meaning that it happens frequently that students finish the quiz in 15 minutes. The quiz will give you a mark, which will be then integrated with the result of the oral. The oral will be very short, like 5 minutes. This also gives to you the opportunity. Keep in mind that I'm making the exam myself to not to stay busy for more than one day or the full day. It may happen that the oral improves the result of the quiz. It may happen that the result after the oral is lower than the result of the quiz. Statistically, my experience is that the changes, the two solutions are very consistent, the 2 marks are very consistent, and if there is a difference with after the mark of the quiz is about 2-3 marks, so it happened that students get 26 in the quiz, then got the max mark 30 after the oral. It happened that there were some decrease of 2-3 marks. Usually there is no big difference between the quiz and the oral. The quiz, in order to get the max mark at the quiz, you don't need to reply to all the questions. All the questions have the same weight and count for 1. So in principle, if there are 30 questions, each question counts for 1. If you reply correctly to all the questions, you should get 30. Actually, what I do is to make a statistical assessment. So usually I give 30 also if a couple of questions are wrong. So you don't need to take the quiz in a very stressful way. I mean, it is just a way of expressing your capabilities and your knowledge with a different solution with respect to the oral. So I think it is an additional opportunity. I will give you some test quizzes to try yourself. And these test quizzes are anonymous. So they, being anonymous, they are structured in a slightly different way with respect to the exam. And the slightly different way is just the fact that if I make a quiz anonymous on Moodle, on Virtuale, Virtuale is using Moodle. It's an open platform for teaching. And if I make the quiz anonymous, I cannot give a feedback on the single question. This is not possible. It's not allowed. I don't understand why. Don't ask me why. So you get the overall mark, like you replied correctly to 25 questions over 30, but you are not told what are the questions that you didn't reply correctly. So you have to try again. It's not a problem because you can try hundreds of times. But of course, it would be more convenient if you got detailed feedback. If I make it anonymous, it's not possible. Of course, you have the opportunity to visit me and ask me, but in this case, it's not anonymous anymore. So it's your choice. It's not a problem. If you really if you really get puzzled, you can come to me and say, I don't know what to answer to this question. I don't know where I am mistaken. Of course, it's not anonymous anymore. Okay, but the quiz is otherwise, if I say anonymous, it's really anonymous. I can show you what I get. I get the number of attempts and a statistical assessment, but not names, no matricula, not anything. So they say you got 30 attempts, and this question was replied correctly by 90% of the students. This is useful to me, because if I see that a question was replied correctly but by only 1 student, I say, something may be wrong here, okay? This is useful, but still I don't get your names, absolutely. Okay, let me see. First of all, no, not first of all. So, how your evaluation is performed? First, think that, to me, the max mark is reserved to an excellent exam. Excellent doesn't mean impossible. And the laude is exceptional. So to me, what is an indication for a laude? An indication for a laude is everything is correct. The presentation is very good. Your presentation is an integral part of my assessment, the way you present. Why is that? Because also for an engineer, it is very important how you sell yourself, but don't take the term selling in a negative manner. I mean, you look for a job, you apply, and then you have an interview. And the interview, you have to sell yourself. You have to present, to show your enthusiasm, to show that you really want that job. So use the same strategy in an exam. You should show your enthusiasm, your effort, maybe your passion. But even if an exam is not really exciting to you, you should show your effort, your commitment, and in a way that the teacher gets it. Because as I said, I think it's important for your education, for building your skills, okay? And so I was saying, the laude is given by everything is correct, the presentation is excellent, is good. I mean, don't take excellent as something impossible. I mean, the presentation is fine, is good. And to me, the laude should include a demonstration of commitment, something like, I realized that you expanded, I mean, or you didn't look only at my web pages, but for some of the topics, maybe that you took some time to read some more. In my web pages, there are a lot of links. Let me make an example. No? Again, I go to the Earth system. Okay, you see here, for instance, feedbacks. It's linked. Okay, if you click on the link, you get a Wikipedia page that explains what is a feedback. So feedback is easy. It's an easy example. Usually the links should open as a new web page, but in this case, it was not. Like holistic. Holistic, maybe some of you don't know what it means. I still have some problems sometimes to understand the meaning of holistic in some context. So there is a link, holistic, and explains dealing or treating. Okay, let's forget about sfida di digiuno. It's not really dealing with or treating the whole of something or someone and not just a part. Okay, and then usually I make an effort not to include links with advertisements. So this one will be changed because I don't like it. So usually I link Wikipedia, but usually, as I said, I don't like advertisements. So Earth system, let's see. Oh, this is a video, or this is another video, but there are some examples of links. There is a video to a link to a blog post, which is I found very interesting. The known unknowns about climate, life, and the solid Earth. So these links, what is the purpose of these links? These links are not usually a matter for the exam. It is some additional information that you don't really need to follow because there are hundreds of links. So I'm not expecting that everybody clicks on each link, okay? But it's additional information. So if you see something that you don't know that is linked, then you should click on that. Or if you see something that looks interesting to you, it's an opportunity. Now, if during the exam I realize that you expanded your knowledge by following these links or by, anyway, reading something additional, this is to me something important to prove your commitment. Of course, it shouldn't be only that. The basis, there must be a good knowledge of the subject, etc., a good presentation. But in order to give you an example of something that pushes me to consider the laude, is everything is good, everything is fine, plus there is a plus. And this is the laude. If everything is good and fine, then it's 30, including the presentation. And then, of course, we go down. I am aware that with the quizzes, sometimes there might be some casual, some randomness. So this is why the quiz, sometimes I give the highest mark, even if there is some question wrong. And this is why I tend to give more weight to the oral, even if it's only 5 minutes. So the oral is something that its randomness is much more limited in the oral. Okay. So this is how my assessment is formed. I think that's it. And just let me say that in order to contact me, you know my email, and it's alberto.montanari@unibo.it, but it's placed everywhere in my website here, and somewhere. I mean, anyway, it's I write it here, but there is a link at the end of the web page with my email. Anyway, it's alberto.montanari, and I'm not. I am sharing the screen, so if you are attending online, you don't see the blackboard, but I'm just typing my email on the blackboard, so you are not missing anything. alberto.montanari@unibo.it. I prefer to be contacted by email. Please don't use the chat of Teams, or I mean, it may happen that I look at it, but not always. The email is my preferred way of communication. Usually I reply very soon. Very soon, I mean by 24 hours, I am able to give a reply. And if you need any additional explanation, we can set up a virtual meeting, usually very quickly, okay? And I think it is the easiest way. I am also available in physical presence to give individual explanation, but I think it is easier to, with individual explanation, I think the online meeting is perfect. But anyway, I am at your disposal. Okay. One final thing. When we have 3 hours, like today, usually my habit is to teach for 1 hour and a half continuously, which means from 9:15 to 10:45. And then I make a stop of 15 minutes, and then the last hour from 11 sharp to 11:45. If you have any problem with the schedule, with such schedule, I can also make a break every hour. No problem for me. And just let me know if you have any preference. On Thursday, what I am proposing is let's see, because online it is the break is more important than in physical presence. So let's see. Okay, there are some lectures that can be delivered from 9:15 to 10:45. Other lectures which may be heavier, it's better to make 9:15, 10, 10:15, 11. Of course, if we don't make a break, we save time. But on the other hand, online 1 hour and a half, it's a long time. So I prefer, let's see, okay, maybe on Thursday we start with a break and then we see, okay. If you have any different need, like I prefer to start at 9, especially online, but it would be relatively easy to start at 9, from 9:45, 10, 10:45. It doesn't make a big difference for me. And so what I am proposing, it's based on my usual habit, but if you have any different suggestion, the only thing that I ask you is maybe to reach an agreement before making proposals. Otherwise, it becomes complicated. Okay. I think, do you have any question so far? Yeah, one question. I can repeat for the people online.
The quiz is a multiple choice test, or?
Yeah, it's a multiple choice. The question is, the quiz is a multiple choice? Yes, it's a multiple choice. I'm not sure if I already have an example. Anyway, I can make available an example very quickly after a couple of weeks when as soon as we get some material, some theory for some questions, I can give you some examples, but it's a multiple choice, yes. Again, with no penalty, only one reply is correct. The choices may be Many, because I started with only 3 choices, but you know, with only 3 choices, I made some experiments by just replying randomly. And with only 3, there is a good chance that if you just pick randomly the questions, you get a good mark. So I decided to increase to 5, 7 in some cases, and with five alternatives, it's more difficult if you just go by chance to. But usually the quiz, I tell you, it's not a big issue, because you know, even if you put 7 questions, if you are used to make quizzes, and I think it is useful because indeed there are also some job interviews where you are asked to make quizzes, or several selections. But if you are used to make quizzes, you know, there are strategies. Like even if you have 7 alternatives, usually there are half of them which can exclude very quickly. And so if you are a bit strategic, it's not a big issue. Other questions? Yeah, another one, please.
Yeah, about the quiz. Is it that we can do it online, or do we have to come in when we do it and just like bring a laptop?
Okay, this is a very good question. The exam is in physical presence, and I cannot make any exception to that. So while I can make an exception to streaming, for the exam I cannot make any exception. So I'm sorry for that, but there is no way. It's something that can be prosecuted if I make an exception, because it's a public act. And if the requirement is that has to be in physical presence, it has to be in physical presence, which means that I am booking a lab with the computers, or maybe that if I have problems with the labs, I ask you to come with your device. And usually it works. What I am suggesting is, in case I ask you to come with your device, not to use. My advice is don't use the phone, because the phone is a bit complicated. The tablet is perfect. And also the personal PC is perfect. Usually the Wi-Fi works well here and in the university, but I will make an effort to go in the lab. But I'm saying this because even in the lab, I had some students asking me, can I use my phone? And the reason is that some students are used to connect with the phone. They are so used that they are not able to connect with the PC. It is strange, but it happened to me. And some students said, I want to use my phone. Of course, if you want to use your phone, that's fine, but I don't think it is a good strategy, because the phone is not as reliable as the tablet or the PC. But in any case, I will tell you if I book the lab or if you have to bring your device, but it has to be in physical presence. Other questions? Yeah?
And about the presentation, should we have to work in group or?
It is possible. It is possible. I suggest you to make, this is the presentation as a part of the interactive activities. Don't build a huge group, because I think it must be recognized what is your individual contribution. So sometimes I had experiences with 3 students presenting 2 minutes each. This is fine. This is fine. If you form a group of 15 people and only one speaks, I don't think it is a good experience. But if you make a group of 2 students, 3 students, I think it would be very nice to make interdisciplinary groups, but it is not easy here because we have only a few students that are not from engineering. Other questions? Okay, good. So if you don't have any additional question, I think we can open the first link. Okay, this is a link that is a bit particular because it's not a web page, but it's a presentation. Let me put it in full screen. It is an interactive presentation. And it is an experiment. So just let's see how it works. To provide an introduction, and this is, I'm using the same introduction to the 2 courses I am teaching. And the introduction is about climate change. So we know it's an issue, but we also know that there are several unknowns. and there are lack of strategies in most of the cases. The lack of strategy may be due to lack of knowledge, may be due to the presence of uncertainty, may be due to institutional arrangement, or to difficulties to seek an agreement. So I think, first of all, we have to get oriented into the problem. So let me move to the first slide. And first, let's look at a couple of issues that we all know, most of us know quite well. So the first issue is the increase of temperature after, let me see, I'm just checking online. Are you seeing my screen, correct? Yes, okay. So increase of temperature, let's look at this graph. From this starts from about 1850 up to 2022. It is very recent. It is, I mean, very recent, I mean that it's updated to the recent recordings. This comes from our world in data. This is a database, it's an open database of statistics on several things. It is extremely interesting, and it is also considered to be reliable. So if you look at the references on the web, it is considered to be fairly reliable. Okay, and so I highly suggest to explore the data that you see there. I got only the data on climate change and sustainability, but there are a lot of issues like democracy, demography, a lot of information from there. I think it is, as I said, it is a good source of data. It's open, and you know the importance in climate change of using open information. I'm not discussing in depth about it, but using open information with environmental issues, sustainability is essential. And you may think that this is very naive, like, of course it is essential. But you have to think that up to 10 years ago, it was considered impossible to put together environmental information at the international level because the data were proprietary data. And the institution who paid for collecting the data didn't allow to make the data public. So I remember 10 years ago that we made an agreement with an Austrian university to compare our data on floods in the south of the Alps with the north of the Alps. And you may think that this is something necessary, trivial. It was impossible. It was impossible because the Austrian government and the Italian government didn't allow to exchange the data with international institutions because they paid for that. So what we progressed in exchange of information, now we have a database that is public of floods at the European level. But it was published in 2017. It was like a dream because up to 2010, it was impossible to exchange data with Austria. So, I mean, we progressed a lot. And think that this has been, sometimes we wonder, did we move forward with the sustainability, climate? And my reply is yes, we moved forward. I tell you. And in terms of actions, maybe that you can still see that we are a bit stuck. But in terms of knowledge, of information, we move forward. Okay. So there is no doubt that we are in a warming period. There is no doubt on that. Sometimes you know that climate change is controversial. There is a lot of controversy, a lot of people discussing and fighting. It is a political issue, it is an economic issue, it is very controversial, but there is no doubt that we are experiencing a global warming. There is nobody questioning that. Some people are questioning on the amount of it, because depending on how you measure temperature, it's clear that the way people measure temperature in 1960 is different from how we measure temperature now. So some people are questioning, like, maybe that the increase is even higher than that, or a little bit lower, but on the fact that there is an increase, that there is global warming, there is no doubt. Okay, and so let's start from this fact. Still, you see that global warming is a bit bizarre. There are up and downs, there is variability. And this is an essential concept which I will recall later. We have also to understand what is variability, not only change. I mean, change, of course, we need to understand change, but we need to understand also variability. Variability means that climate is not constant. It's not a straight line. I mean, there is, if there is a trend, the trend is superimposed over variability. And this brings a part of the controversy. But in any case, in general, it's increasing. It's increasing in what way? First, okay, here we start from the beginning of the so-called instrumental period. What does this mean? We started measuring temperature. We have temperature measurements starting from about 1850. Before than that, we don't have measurements. And this is a big problem. Not only for temperature, think about rainfall. Rainfall is very easy to measure. You put a tank outside, and then when it rains, you go there and you measure. It is very simple. And in fact, the first measurement of rainfall were done in this precise way. People putting a tank outside every day, going there and measuring with a ruler the amount of rain. In several days it was 0, but in several days there was some water in that, and therefore the depth of water was taken as a measurement of rain. It is very simple, but the oldest measurements we have of rain go back to 1725. It's a very short period. In the human history is nothing. Think at geologic times. I don't have a word to define it. If it is nothing for the human history, in geologic times, 200-300 years, it means no knowledge. And it is a bit strange that humans, which started to observe the stars like 3,000 years ago, I don't really know, but it is something like that, humans didn't think of starting measuring temperature, rain. It is strange, probably because they had different needs. You know, we humans, we move forward in order to satisfy our needs. And probably in the past, they studied the star because they had the need of getting oriented in the sea, in the navigation. But probably rainfall was not a problem, was not considered to be a problem. And the temperature was not considered to be a problem. But this is a big issue. And for this, we have alternatives to fill the gap, like proxy data. We will talk about that. But still, this lack of information on the past, it is a big issue. On the other hand, we can see that during this period, there was an initial part that looks like no big changes, variability, yes, but not big changes. And then there is some warming here. And then a cooling afterwards. And then, starting from about 1980, a constant increase, a sharp increase, with some hiatus around here. There was a period that was a bit, it was between 2010 and 2015. There was, no, probably between, not probably. It was between 2005, 2015, the so-called hiatus, during which temperature stabilized, and then there was a sharp increase between 2015 and 2019. In the past, these are monthly data. In the past 3 years, it looks like there has not been a sharp increase again. But you know, these are short periods. It's difficult to make any assessment based on a short period. When we talk about climate, usually we have to look at windows of at least 30 years. And if we look at the longer time period, it's clear that there is this increase, recent increase. And again, everybody agrees on that. Now let's look at the second graph. This is global freshwater use. This is, I mean, impressive and shows what is called the Great Acceleration. If you look on the web, I'm not linking this because it's not really a matter for this subject, but we use the term Great Acceleration to mean the acceleration in human development after 1950, after the Second World War. And you can look at the Great Acceleration with several indicators. Demographic, for instance, and it is, you know, that this is becoming a very important discussion nowadays, this big increase in demographic after 1950. And I think water use is related to demographic, and the sharp increase in water use, it's a clear sign of the Great Acceleration. And it is amazing if you see the increase. And this poses two questions. First, should we consider these two graphs related in some way or not? Of course, it is difficult to say no. And the second question is sustainability. Great acceleration, these water uses, this increase of temperature, global temperature. And this is the essence of our problem. This is the essence of climate change, which is strictly related to sustainability. And the two issues are to be studied together. They are strictly related. And they call for action, in a way. In principle, it's not needed. In principle, if you look at the history of humans, humans reacted to changes by adapting. Humans were not used in the past to make prediction in the long term. Usually they made prediction, for instance, for strategies in the short term, during wars or during pandemics. But usually humans were not used to make predictions in the very long term, like from now to 2100. Okay, so in principle, we could also say that it's not part of our history. We could move forward according to what we have always done in our history. On the other hand, it's clear that if you look at the history, we also experienced several problems, several recession periods, if you look at the history of the Roman Empire, for instance, no? there were periods of recession after the failure, the collapse of the Roman Empire. So if we don't make an effort to make long-term prediction, if we don't make an effort to try to take an action, we have to accept the idea that there could be some impactful consequences. So, of course, given that we progressed in technology, we progressed in knowledge, the question is how can we use this knowledge? How can we use these progresses to get prepared to what's going to happen? And of course, we need predictions for that. We need also a forward-looking approach, and we need an interdisciplinary approach, because you know, the problem is so complicated, involving so many aspects of environment, so many problems. Water is one, but other ones are energy, which is very popular today, or several other issues related to our sustainable development, that an interdisciplinary approach is needed. And in particular, I think that the role of the engineers when it comes to strategies, to actions, there are roles, disciplines that have to take decisions through design. So these disciplines may be economics, maybe indeed politics, political sciences, and engineering. Engineering has also to make design of infrastructures. And we need to seek a cooperation between these disciplines, because you cannot consider any of these competencies, any of these disciplines disjoint. If we consider them disjoint, the result is very simple: no action. So if everyone looks at an individual perspective, when it comes to the discussion, to the debate, there is a controversy. So if we look at the perspective of engineers, I make you a very simple example. An engineer, if it is asked to solve the problem of water scarcity, of water security, the answer of the engineer, the most natural answer is Adam, is storage. Okay, perfect. Now, if you get the natural scientist, the reaction of the natural scientist is the environmental impact of Adam is unsustainable. So there must be a different solution. If it comes from the economist says, I don't have any resource for building a dam. And the result is simply no action. So if we don't seek an interdisciplinarity, when it comes to the confrontation of the different perspectives, which is an added value today. We are living in a democracy. I mean, in several parts of the world, there is a democratic approach. It's a different story if you look in Italy now with respect to the period of fascism, during which we made a lot of infrastructures because they were decided with a top-down approach. In a democratic approach, there is a discussion phase. In the discussion phase, usually, if you don't prepare a preliminary synthesis of different perspectives, there is a controversy, and the controversy is no action. The problem is not simple, and the question is how can we give a contribution on that? And this is a big issue, and I think we need a positive approach. We need a constructive approach, not destructive. Unfortunately, a problem in these discussions between different perspectives is that there is, in many cases, an approach that is not constructive, it's just destructive, aiming at stopping any action that we don't agree with. And this is destructive because, of course, if every part involved in the discussion stops and aims to stop any action they don't agree with, there is no action. It is clear. It is a clear result. Okay, let's move forward. What is climate change? This is a first interactive slide, and I would like to know your opinion, so I want to embarrass you and ask you to give your perspective. I am suggesting some results, some possible answers here. There is one most appropriate answer. So, what is climate change then? Because everybody knows about climate change. I was inspired to ask this question by an international colleague that was invited to deliver a lecture on climate change, and he's a glaciologist here in Bologna. And he asked a different question, actually. He asked the audience, it was the start of the lecture, he asked the audience, do you think that climate change is human-induced? And let me just make a premise on that. It is a very controversial question. So when I said everybody agrees on global warming, if we ask some more specific questions on climate change, they are more controversial. And so the question, this person is intimately convinced that climate change is human-induced. He published a lot of papers. But he wanted to start with a very provocative question, like, do you think climate change is human-induced? And the audience said, yes, of course. And everybody agreed on that. And then he said, okay, perfect. And why? Why do you think that climate change is human-induced? And the audience gave different questions. Nobody gave the correct answer. And I am curious, I would be curious also to know your opinion on that. So let's assume that, so the question is, let's assume that you are convinced that climate change is human-induced, and why? Do you have any idea? Do you dare to give you an idea on that? Yeah, please.
I think that,
don't look at the slide, it's a different question.
Okay. I think that it could be human, human responsibility from looking at the trends of the increased use of fossil fuels and the consequent CO2 emissions, and the fact that we have a mechanistic idea of why CO2 and other GH emissions can increase the warming, the global temperature, and then we can do a correlation between the two. So this is the mechanistic way that we could say that human actions induce global change, global climate change.
Okay. Let me say that in my opinion you gave two answers. One answer is if I look at the global emissions, human-induced emission and temperature, there is a correlation, and this is an answer. And another answer is we have a mechanistic understanding that explains that if we increase the CO2 emissions, there is an increase of temperature. I think they are related, but other ideas? I tell you, I don't want to embarrass you, so I don't want to force other answers. I tell you what came from the audience when my colleague asked the question. And actually, your reply didn't come in that case. The replies were, there is an increase of temperature that is unprecedented. And therefore, being unprecedented, it's clear that it's not part of a natural variability. And the reply of the expert was wrong, because in the past, and then he showed some graphs, we had similar tendency in the pre-glacial period. And so he said wrong. And this surprised me because I was indeed convinced that this would have been my answer, like it's unprecedented. He said wrong. And then there was another answer which was similar to what identified as the first part of your answer, like there is increase of CO2, increase of temperature, and therefore it's clear that there is human influence. And he said, wrong, because when there is an increase of temperature, you have an increase of CO2. In the past, we had CO2 concentrations in the atmosphere that were much higher, because what happens is that when you increase temperature, there is an increase of release of CO2 from the oceans. So he said, wrong. It's not appropriate. I must tell you, there has been recently a very controversial paper published on the Journal of the Royal Statistical Society of the UK, where they took the long-term records of temperature and CO2. And they show there is an high correlation, and this is not a new result. This is has been known for a long time, but they proved with a statistical approach that on average, the increase of temperature was anticipating the increase of CO2. Very controversial paper. Some people said that is wrong, but I'm just reporting the information, just to confirm that we cannot say that it is the relation between the two indicators, CO2 and temperature. There were other answers that I don't remember, and then he provided the reply. He said, the only proof that we have to say that climate change is human-induced is given by climate models. It's given by our mechanistic understanding. So it is given by our theoretical knowledge. This was a surprise to me because I think we had more. Keep in mind that I'm not a climate scientist. I am an engineer, I am an hydrologist, so I'm more, my expertise is not in climate modeling. So I thought that we had more. But actually the reply in that case was that it's climate models that confirm that. So in climate models, if we increase the emissions, like in the, you know, that climate model, you may know that they work with scenarios of future emissions. If we increase the emissions, there is a higher increase of temperature. And for now, let's only talk about temperature, okay? But because I think temperature is a clear evidence. And let's now focus on a less controversial question. I didn't want to put this question on the slides here because I want to avoid talking about controversy. Let's talk about a positive approach. And then I just wanted to put this question in order to clarify what is climate change. So it's a global deterioration of climate. It's the occurrence of unprecedented extreme events. It's a global increase of temperature. Or it's a long-term shift in weather patterns. So, of course, you may check here. No, sorry. If you click, then you get the answer, okay? And I don't want to raise the question again. Let's just say that the correct answer is the last one, is a long-term shift in weather patterns. It's not only a global increase of temperature, and it's not only the occurrence of unprecedented extreme events, and we cannot say it's a global deterioration of climate, because we cannot say that climate change is necessarily a deterioration. There are some countries which are profiting from climate change. So it's not to be, I mean, we have to be aware that it's something that is extremely complex, and this makes also clear what is the reason of the resistance of some countries to act against climate change. So it's a long-term shift in weather patterns. At this point, there is another question that comes to our mind. What is weather? What is climate? It is extremely important that we understand the difference between the two. Extremely important. And here there is an exercise, complete the definition. First of all, if I click on change is a long-term shift in weather patterns, you get the correct answer, okay? And at the end of the story, you have also an assessment, an evaluation, and there is a comment. The comment is the most compelling evidence of anthropogenic influence in climate is provided by climate models, which, this is a comment which I put on there because I think it is an additional information that is important. Now, weather and climate. So here, if you read, place the missing word to complete the definition of weather and climate, you have to place climate, one occurrence, and weather, two occurrences. Use the capital for the first letter. Okay, so let me make it. Weather refers to the day-to-day state of the atmosphere, day-to-day, such as the combination of temperature, humidity, rainfall, wind, other factors. Climate describe the weather of a place, average of a period of time, often 30 years. Okay, so climate is a statistic. The weather is an observation. Weather is observations. I observe rainfall, I observe temperature, day to day. Climate is statistics of weather in the long period, like usually 30 years. So we cannot say today's climate. If we say today's climate, we implicitly admit that it's averaged over 30 years. And here, if we check, we get the answer. And there is a comment. Think about it this way. Climate is something that can be expected to happen in general, like a cold winter season, whereas weather is what a person might experience on any given day. like a snowstorm in January or a sunny day in July. Okay? So when we talk about climate change cannot explain a day in January of 15 degrees, cannot explain 1 year in which we get an extraordinary temperature. Let me go back to this graph here. If we look at this period here of warm period, which lasts like 10 years, this is not climate change, this is climate variability. This is weather variability. If we go here and look at this here, this was a month with a temperature that was very low, very recently, maybe 1 year ago. I think it was a cold month. It was a cold month in, I don't remember when, but it was very recent. This is not climate. This is the expression of variability. So be clear and remember that this is a question that will come out in the quiz. Definition of climate, definition of weather, with several alternatives. Okay, and it is an essential premise. Let me just look at the next one and then we make a break. Okay, change and variability. It is related to what I just said. Let's make a break now. Okay, 15 minutes. I take a coffee. And one thing, before you leave, I leave the video going, I stop the camera, I stop the micro, and I leave the video going, because otherwise, if I take 2 videos, it's a mess afterwards to put on the web. You will know that in your video, you will have also the break with no camera, no micro, okay?
Una comunque for något är kyla, är har essential och men något
Okay, one thing, before I restart, I got several questions from you, and not only in presence here, but also by email, regarding the possibility to anticipate the exam date. I will do my best to get information, and I get committed to make the exam as soon as possible. I don't think it will be possible to make it before June 9. I will check if it's possible to make it on June 9, the first one, okay? Before than that, it's, and I don't think it will be possible because I am explicitly asked not to make exams before the end of the calendar lectures for several reasons, not only because you have to attend the lectures before taking the exam. There is also another reason that I tell you for your information. Even if we are finishing the lectures in May, some of you told me, why are you asked to wait? The reason is very simple. Until the lectures are not finished, if some people schedule exam in that period, the students will not attend the other lectures anymore because they have to take the exam or they have to study for the exam. So this is another reason why they ask not to make any exam during the lecture period. I know that some of my colleagues do that, and I can't do that. Please stick on me because I am particularly monitored for several reasons. This is an experimental course, and therefore people are monitoring me to see if how the course is going. So they are monitoring also my exams, etc. So I am sure that I am picked up if I dared to make the exam in May. So I'm sorry for that. I will do any effort to make it on June 9, okay? But before than that, it's not possible. Okay, and I will keep you informed, okay? Because in principle, June 9 is a Friday, so if I think I can do the exam that day, but let's see, okay? Okay, now let's go back to the definition of variability and change, and this is another definition that you may encounter in your quiz. And variability, let's look at the graph first. You see two series of temperature change with respect to the average, okay? And so basically here it's temperature, and but it is expressed with respect to change with respect to the long-term average, okay? And so you see that in Northern America, temperature is increasing a long time from 1850 to 2027. We already discussed this. Also in tropical America, here I put southern, it is a mistake, I have to remember to correct it. In tropical America is increasing. So, I mean, this is consistent with what we said, but you see that the two temperatures are behaving in a very different manner for the other features besides the trend, the increasing trend. And in particular, the up and downs are behaving in a very different manner. And the up and downs are a sign of variability. The trend, the increasing shape, is a sign of change. So, on the one hand, I think the definition is clear. So, variability, it is how spread out or closely clustered a set of data is. Okay, so variability is there, even if on average, you don't have an increase, you don't have a shift, okay? Change is a shift in patterns or a shift in statistics. Doesn't make, but let's say shift in pattern, okay? So the definition is clear on the one hand, and remember this definition, again, because it is extremely important for your exam, but also for your education. Why it is extremely important? Because you can see from the blue graph that variability may hide the detection of change. There are some years where variability produces a higher temperature with respect to the increasing trend. So even in absence of change, you may have extremes. This is extremely important. Pardon, excuse my repetition. So it is extremely important, the fact that you may have extremes, even in absence of change, if you have a lot of variability. But this is a big issue scientifically, to distinguish between change and variability. So you see the last sentence, understanding variability of climate is important for mitigating climate risks and adapting to them. And there is one thing that it is particularly important for an engineer, which I often recall when I talk to people, because sometimes people discuss about the causes of climate change. And so people discuss about, okay, climate change in temperature is clear, but for rainfall, it's not really clear if it is something that is changed or not. And my reply is, look, I don't care about the causes. I care about the fact that we have extremes. We have people that die. We have floods. We have droughts. We have that, and that. So no matter the causes, we have to do something. And this is, I mean, something that highlights the need for adaptation in any case, even if we don't want to care about climate change. So, but in any case, we need to take action for adapting, for mitigating the impact of these extremes. And so understanding this difference between variability and change, in any case, helps us in understanding what is the best action. Okay, now, okay, I didn't remember, sorry, that I also put the question of my colleague. So, but let's skip this. We already discussed about this. So these are possible answers. We already know that climate models cannot, we know the correct answer is one. Correct, very good. Okay. Let me skip this because we already discussed it. Okay, some numbers about climate change, and keep in mind that it is extremely important to have an idea of what means something we are concerned about in practice. It is extremely important to be able to give numbers, to know the numbers, and to understand them. And especially with climate change, it is extremely important because there is a lot of misinformation around. So there is, I realize that the numbers are not very clear to the general public. So how much the global temperature, there is a spelling error there, has raised since the pre-industrial period? About 1.3 degrees centigrade. Okay, I say about because there is some discussion on the measurements as I anticipated, but this is the order of magnitude. So the global temperature, we are talking about 1.3 degrees. There are some hot spots. So the Alps, for instance, are an hot spot for a reason that we don't yet know. We don't know yet. The temperature in the Alps has increased about 2 degrees, so more than the global average. There are also cold spots, and look at the second item. Temperature increased more in the northern hemisphere. If you look at the southern hemisphere, the southern hemisphere has increased less the temperature. And in the past, during during the glaciation period and the interglacial periods, there were different situations where the southern hemisphere increased more the temperature during the warming periods. But actually now the situation is that the northern hemisphere has a temperature increase that is higher. Keep in mind that these numbers may differ a little bit depending on the instrument that you use for measuring temperature. 1.3 refers to ground temperature measurements. In the southern hemisphere, we have less measurement points because there is a dominance of oceans. So we have less measurements. If we look at satellites, satellites can estimate the ground temperature with some more uncertainty, and basing on satellite measurements, the increase of global temperature is a little bit less than 1 degree. So there is a slight difference. Even satellites, they do see an increase of temperature, but not as much as the ground measurements. Sea level rise, this is what people are more confused about. Since 1880 to 2020, the sea level rise is about 21 centimeters. So we are not talking about meters if we look at the historical measurements. The sea level rise is due to two contributions. It's the melting of the glaciers, the melting of the polar caps, and the expansion of water after the increase of global temperature. And keep in mind that the sea level rise, we will discuss it, there is no sharp increase in the past 30 years. It's a constant raising of sea level from 1880 to 2020. There is a little bit of, but very, very minor increase in the past 30 years, 30, 40 years, but it is very, very minor. So it's a tendency that didn't change much. Just to give you an idea, during the last glaciation, the sea level was 120 meters lower than today. So when we talk about this increase, we have to place it in the correct context of the order of magnitude. And the last glaciation, in terms of global temperature, it was minus 10, something like that, minus 10 degrees, okay? Okay, global CO2 emissions have raised from about 5 to about 35 billions of metric tons from 1940 to 2020. It's a sharp increase due to the great acceleration. Okay, it is indeed a sharp increase. But if we look at global CO2 emission per capita, they increased less, from 2 tons in 1940, about 4.5 tons in 2020. It is increased, but it is doubled. But if you look at the global emissions, it's from 5 to 35, it's an increase of an order of magnitude, almost an order of magnitude, 10, almost 8 times, 7 times. And of course, this means that the global emissions also depend on the population numbers. And this is, of course, clear and highlights that the problem is, has many facets, because it is indeed difficult to decrease the emissions if the population is increasing. So the global CO2 emissions also increased for the effect of the development of society. CO2 concentration in the atmosphere increased about 25% from 1980 to 2020. And it is a significant increase, indeed. Global economic losses from weather catastrophes are about 300 billions of US dollars, steadily increasing over time. This does not mean that they are due to climate change. This is a different number. I'm now talking just about global economic losses from weather catastrophes. They are steadily increasing. Of course, you may say that they are steadily increasing not only for climate change. They are also steadily increasing because the population is increasing. So if you get a flood in a desert area, it's different than getting a flood of course, in a populated area. But still, these numbers show that there is a problem. I mean, if I only look at the last one, as I said, there is a problem to solve. If we have global losses that are steadily increasing and the global number of people who die who are steadily increasing, this is a problem. Keep in mind that it is also a problem in terms of equality, diversity, and inclusivity. The people who suffer more from global problems are the people who are disadvantaged for several reasons. And the categories that are disadvantaged, less included, that have less access to economic means, they suffer more. It's like the increase in the bills for the energy costs. Of course, if a family has a good economic means, it is not a big problem, the raise in the bills. If a family doesn't have good economic means, it's a big problem, it's a huge problem. So we have to keep in mind that, unfortunately, these global problems are increasing the global disparity. And we know that this is an emerging issue today because global disparity triggers migration, triggers social conflicts, which are affecting at the end the whole society. And I mean, these numbers clearly show that there is a problem. Okay. Now, this is something that, I mean, it is a conjecture that what we are observing now, the warming that we are observing now, is unprecedented in the past 2,000 years. So I mentioned before that in the past we had some periods where the Earth was warmer. But if we limit our focus on the past 2,000 years, the warming is unprecedented. There is some variability, but on the other hand, you see that this sharp increase is clear. And keep in mind that during the Roman period and during the medieval period, there was a climate optimum. Climate optimum is defined as the warm period. And then there was a little ice age from 1500 to about 1750. Just to be clear, the glacier retreat started around 1750. So the glacier retreat that we are observing today started about 1750. Just to understand what is the effect of variability, the little ice age is unexplained. There are some theories that try to explain it, but it is unexplained. But after 1750, the temperature started to increase, and then there is the sharp increase observed recently. This figure, it is showing, is taken, I think, from the IPCC. Yeah, from the IPCC. I have to explain what is IPCC. I think many of you know it, but let me just make a focus. This figure is taken from the IPCC report, which explains what I said before. If we use models, we can make a simulation of the climate without the CO2 human emissions. And this is the simulation that you see in green. If we include the human emissions, we can explain the observed rise in temperature. So this is explaining what I said before. Climate models confirm that there is this human influence on climate. You may ask me, what is the shaded area? The shaded area is uncertainty. IPCC recognizes the presence of uncertainty. Uncertainty which is due to our still limited knowledge of climate dynamics, of the climate system. So different models explain climate in a different way. So this band, given by the shaded area, is intermodal variability. If we set up different models, we obtain different responses. Okay, and you may ask me, what is the difference between models? There are assumptions that are different. There are initial conditions that are different. I mean, initial condition means my initial knowledge of the state of the climate. If I go back to 1850, I don't know the initial state of the climate. I don't know what was the state of the climate at that time, so I have to make different assumptions. I don't have measures of CO2 concentration. I can get some proxy data, but not direct measurements. And therefore, I start with the different model setting. And also the models are different because the scientific community is evolving. And they differ for several internal behaviors. We cannot go into the details. We are not interested in the details. But this gives this uncertainty. Perfect. We just have to be aware of that. If we look at this graph, even if we account for uncertainty, even if we take the lower simulation of the human-influenced model and the upper simulation of the non-human influenced model, we still see a difference. So this graph, in a way, says that no matter uncertainty, there is a human influence on climate. It is confirmed. And I will talk some more about uncertainty with the next slide. But first, let me say something about IPCC. So IPCC, I'm just writing on the blackboard the name IPCC. So who is attending online is not losing anything. Stands for International Panel or Intergovernmental, I don't remember, let me check. Because I have an amnesia. Okay, IPCC. Intergovernmental Panel on Climate Change, and I am opening now the web page so you can see. Okay, it's a United Nations body for assessing the science related to climate change. IPCC is producing a series of reports. It is a recommendable reference if you want information of climate change, on climate change. Yeah, please, a question.
I have a question on how the 0 point is set, or where the 0 point is set, because we always see those graphs and the temperature increase over time. And you said that if we look at climate, we usually average over 30, we look at 30 years. So where is the 0 degree point, and is that consistent for many different papers or research projects, or is it always set a little bit differently?
Okay, the question is how it is set, the 0 point in these graphs, correct?
Yeah.
And also you said whether it is consistent with several research project interpretation, and then you asked, okay, let me talk about first about the 0 point. Usually these are graphs. I didn't include the, let me just 1 second, because there is not caption on the y-axis. I'm noticing it now. Okay, usually the 0 point in these graphs is set at the average of the observed information. So if I look at the left graph here, I think that the 0 should be the average of the historical information. I think it is consistent with what I'm saying. And so usually it's expressed in terms of anomaly, the 0 point, in terms of anomaly of observations. And I think here should be the same thing. And I think it's okay, because here is below, for a lot of time is below, and then is increasing. I need to check in this specific case, because it is taken by the IPCC report, so I need to check from the last one if the reference is indeed what I said. So, but I can tell you that usually it is the temperature is expressed as anomaly with respect to the long-term average of observation. This should be how it is reported here.
But that means that depending on which period of time I look, I have different increases of temperature. So if we say we have a temperature increase of around 1.3 degrees, that only refers to a very specific amount of time.
Okay, when I say that the temperature increase is 1.3 degrees is computed in this way. You take average over a time window of temperature, like in 1880, you take the average of the observations during the period 1875, 1885, and this is your starting point.
That's the zero.
That's the zero.
Okay.
And then the length of the window may vary. So some people, in this case, I think it is 10 years. Let me see. I think it is 10 years. I'm not sure if it is specified here.
10 years.
10 years. Where do you read it?
Because it has 5 separate parts, and it starts with 1815.
Okay.
And it goes to.
Yeah, correct. It's 10 years. Yeah. But in other cases, it's 30 years. But the zero, now I understand your question. The zero, it is computed as average along a window. And so if you take the average between 1875, 1885, it is the zero for 1880. And then you go to 2010, 2020, you compute the average, and the average is increased 1.3.
Okay, but there's no international agreement on which 0 point we choose. So you have to specify it in your paper and say, we took the time period 1875 to, okay?
Yes, there is no international agreement on that. And for instance, some people prefer to refer to the last 30 years because it is clearer that there has been an increase. If you start from 1880, you have up and downs. And what is more compelling is the increase in the past 30 years. So some papers start from 1980, 1990. And another thing is the measurement. As I said, if you use satellites with respect to ground measurements, it's a different statistics. And there is no international agreement on that. Okay. But in this case, you pointed out correctly that it's not clear how it's measured the zero here, the zero in the graph, which is a different question with respect to the question that you asked. Okay. Okay. Now let's go again to IPCC. No, sorry. IPCC. Okay. Here it is. IPCC is a body of the United Nations that is in charge of assessing the science related to climate change. It's composed by international experts. It produces reports, which are reported here, synthesis report. I'm providing this information to you. It's nothing related to the exam and nothing related to our course. I just wanted to tell you what is a relevant source of information. If we look at the report here, and I think this is the last one. Yeah, AR6 means assessment report number 6, synthesis report climate change 2023. So let's look at it. Good. And then if we go to the different, it is a very long report. So what I suggest, if you look at it, it's to start with the summary for policymaker, which I should be somewhere here. Summary. Okay. The summary for policymaker, which is not linked yet. Maybe that it's not yet read. The summary for policymaker is something very easy to read, 5 to 10 pages. If we look instead at the physical science basis. I think, let me see, the graph that I copied on the slide should be here. Let's see if it is quick enough. And no, this is just an outline. So I clicked on the wrong working group. Okay, this is the outline. And I don't find, just 1 second, the link to, okay, I don't want to lose time on this, but there is here, let's see, okay, read the report. It's a bit complicated, but we get there. And summary for policymaker. Download. Just I dedicate some time because the summary for policymaker is not long, and it's here is the graph that I took. Okay, here is the graph, and now I have to read the caption to understand how they fixed the zero here. But probably it's here. But let's forget about it now. Okay. This is, as I said, a very compelling reference where you can find a lot of information. Keep in mind that it's not the only one reference. There is a literature that is fortunately or unfortunately growing up very quickly about climate change. So it's the IPCC is not the only one reference, and really an effort, a substantial effort is requested if you want to stay updated. Okay, let's go back here and let's move forward. And just, I wonder whether I missed something. Just 1 second. No, okay, perfect. Now, here there is another question, and the essence of this slide is to highlight that when we talk about the disasters which are related to climate change, which are connected in some way, water-related disasters are the most impactful. And this explains also why the science, the water science, is much interested in climate change. It also explains why a person like me, I am a researcher on water. I got interested in climate change because there was a clear connection. There is a clear connection between the water-related disasters and the climate change. And this also is the explanation why climate change is dealt with also in water science. Okay, and it's the graph explains what are the most compelling, the most evident, the most important disaster that occurred in 2022 related to climate. So we have the Hurricane Ian. It was the most impactful. But then there is the drought in Europe in 2022, which was the second, the floods in China, the drought in China, the floods in East Australia, and also other floods and droughts around the world. So what is the major problem here? The major problems are floods and droughts, and this explains why I am often mentioning floods and droughts. I started with floods in my activity, in my research activity. Now I'm more focused on droughts because the recent occurrences in Europe clearly showed that it is a risk that is increasingly concerning. Now, look at the question here. And so what is the frequency of floods increased at the global level? And select the most reasonable answer. So yes, it is increased. Okay, let's forget about the third one. No, it's not increased. It's clearly not possible because if you look at the left graph, it's increased. But for what reason? and it is increased for the effect of land use change, for the effect of climate change, or it's the combination of these two drivers. Of course, the correct answer is the combination. And indeed, there is a combined effect causing the increasing impact of floods and drought. There is an effect of climate change, but there is also an effect that is due to the fact that we are not prepared to it. And we are developing a lot, and therefore it's increasing our exposure to floods, but we are not taking any action to get prepared. Let me close with the next one, uncertainty, and then it's not finished the lecture, but I just wanted to make a final focus on uncertainty. I briefly mentioned that there is an uncertainty that is given by the different response of different models, but it's not only that. So uncertainty, it is extremely important, especially for an engineer, and let me explain to you why. As an engineer, we are in charge. Who is engineer? He's in charge of making a design and designing an infrastructure, designing whatever. And the engineer, fortunately or unfortunately, brings the responsibility for the design that the engineer makes. Responsibility means that if we make a mistake, we can be prosecuted for that. We are responsible of damages and loss of lives that can be caused by a failure of our design as engineers. But the same could be said to other disciplines, of which I'm less expert. Responsibility means that when we make a mistake, we have to prove that we did all of our best to avoid it. When we are prosecuted, we are absolved or charged, depending on our capability to explain that we did our best to avoid it. So, the avalanche of Rigopiano in Italy, which I think you heard of, it was 2018, I think, they built an hotel in a place that was hit by an avalanche. So they had to prove that they considered, when they designed the hotel in that location, that they considered the risk of the avalanche. And we can make several other examples. And in order to prove that we did our best to avoid the mistake, we have to demonstrate that we considered uncertainty. This is a fact. It's something that shouldn't be discussed. It cannot be discussed. When we make a design, we have to prove that uncertainty was carefully considered. And actually, engineers are used to that. They are used to deal with uncertainty for anything. Think at people that are designing buildings in an area exposed to earthquakes. They are used to consider the uncertainty of an earthquake. This is something that it's part of the background of an engineer. On the other hand, when we talk about climate, it's not clear what uncertainty is. And I talked about uncertainty measured as a spread by different modeling results, but it's not enough. I can make an example for instance, again, refer to the earthquakes. If I use the earthquake modeling, which we know that it's highly uncertain, and I quantified uncertainty by just looking at the spread of different models, I would be for sure charged, condemned if something happens. Because the way they consider uncertainty is by looking at statistics usually. And therefore, they cannot use the spread of different models. So with climate, we have to be very careful, because if we are called to make a design, to decide an action, and we consider uncertainty only by looking at the spread by different models, this is something that is not possible in design. This implies taking a huge risk. So it cannot be only models. And therefore, this raises a big question mark. And keep in mind that when we talk about climate and sustainability, there is a huge debate in science, which basically discusses whether we should convey what is uncertainty and the meaning of uncertainty. Because it's clear that if you make a prediction of a situation that requires a urgent action, and you highlight that the prediction is uncertain, the effect that you obtain in terms of communication is to lower the attention of the public, to lower the attention of the politicians. So some people say we cannot say that climate change is uncertain. We have to say that we are certain about it. On the other hand, from another perspective, there is the engineer who says, I need uncertainty, I need a measure of uncertainty. And this is why I put a slide on uncertainty, because this is a big question mark from a scientific point of view. So we will talk about uncertainty in our course. On the other hand, you know, it's something that we still don't know how to deal with. So this is the problem with climate. We know it is a problem. There is evidence that it is a problem. But when we go to the practical part of it, what should we do and how should we make technical design? The engineer is getting lost because we don't know how to design in the presence of climate change. We are told that our usual traditional methods cannot be used anymore. On the other hand, we are not told what we should do. And this is why the topic is interesting and exciting, because it's us that we have to elaborate ideas. We have to realize the problem and to elaborate ideas. And this means it's exciting. Just give an answer to this question. What is uncertainty? And it is interesting to wonder what is uncertainty. And I would say that more than one question can be correct here. On the other hand, there is one that is more appropriate than others. And let me see what is, because I don't remember. I would say that uncertainty means limited predictability. It's not necessarily due to lack of knowledge. Of course, I have the advantage that I made it. Okay, and I think I'm not done with, but let me say, I think I have just one which I could leave to you. Yeah, just this is the last one, because the last one is the result of our performances in answering the question. Just read this, and which is basically what is science, because we need to take a scientific approach. So let's realize what is science, which is different from other type of knowledge. And I think with this, this lecture can be considered concluded. Okay, any question? I took 5 minutes more of your time. So we meet online on Thursday. I will be online from about 9, but I am starting at 9:15, okay, just for you to know. And Thursday, I will lecture again, not exercises for now, okay? Good, thank you very much. In particular, thank you to those who attended online.
Ale, mamy też.